Hello, and welcome to Let's Talk Tech with DeepCore Data. I'm John Brewer, the owner and founder here at DeepCore, where we're using education to help companies make the right technical decisions. Today we're going to talk about, at a technical level, how the internet works.
In previous episodes, we talked at length about version 4 of the Internet Protocol. IPv4 still carries the vast majority of traffic on the internet, but it has a problem. Because there are only 32 bits in an IPv4 address, there can be at most about 4 billion public IP addresses at any given time. With 7.5 billion people on Earth, you can see the problem. This only gets worse when you consider people have more than one internet-connected device. Some estimates put the total number of devices around 8.4 billion. As you can see, we need a bigger house. As internet-connected devices became vastly more common and the social media age began, it became clear we were going to need a lot more than 4 billion addresses. IPv6 is one proposal for dealing with that problem. But the question is it a little too late? Let's dig in.
So how does IPv6 differ from IPv4? What makes it better? If you already have a reliable Toyota Corolla, why upgrade? Do you really need that SUV? Wait a minute, where did SUVs come into the equation?
Well, you see, the most obvious change with IPv6 is the increase in address size. Whereas an IPv4 address is 32 bits, usually written as 4 decimal numbers, IPv6 uses a 128-bit address, written out as 8 sets of 4 hex digits. A hex digit is a way of representing numbers using the digits 0 through 9 with their usual meanings, plus the letters A through F. In mathematics and computing, this alphanumeric combination is used to represent the numbers 10 to 15. As each hexadecimal digit represents 4 binary digits, it allows a more human-friendly representation of binary-coded values. However, it will make IP addresses a bit longer and more complicated than we're used to. This is where we start to see the practical implementation issues surfacing. This additional complexity will allow for something like 3.4 times 10 to the 38 possible IPv6 values. This is a number of addresses so large, we humans don't really have a good way to conceptualize it. For comparison, there are approximately 100 billion, or 1 times 10 to the 11th power, stars in the Milky Way galaxy, and an estimated 70 billion trillion, or 7 times 10 to the 22nd power, stars in the observable universe. These numbers don't even come close to reaching the amount of addresses IPv6 contains, and the universe is about as close as physical comparison gets. In practice, large swaths of the address space are allocated to special conventions, but the address space is still titanic by any stretch of the imagination. So now back to the original question. Is it worth trading in your small but efficient 4-cylinder for the shiny, impressive V8 engine? Bigger may not always be better when it comes at a cost. So just as a V8 brings more gas, IPv6 has its own benefits and issues. For example, IPv6 requires a local link address. What's this? It's an address in each network interface assigns to itself. The host machine figures out a 64-bit identifier for that particular interface, usually based on the Ethernet MAC address or just selected at random. The local link address is just a specific prefix, FE80, with an interface identifier put at the end of the address. So, for example, if my MAC address were to look like this, my IPv6 local link address would be this enormous string here. Because MAC addresses are already unique on a given network segment, and that FE80 addresses aren't routable outside of our local network segment, we know that we have a unique address that we can use to talk to nearby machines. Now that local link address has a lot of zeros in it. One important shorthand in IPv6 is that anytime we have a long list of zeros, we can abbreviate it with 2 colons together. So that very long address could be written as this somewhat shorter address. As with IPv4, when we discuss blocks of IPv6 addresses, we describe them from left to right, with a slash and a number indicating how many bits are prefixed on our block. So if we're discussing the whole block of addresses that start with 2001, we'd call it the 2001/16 block. For the global network, IPv6 addresses are distributed in much the same way as IPv4 addresses, except in much larger blocks. For example, today you might pay $250 for 255 IPv4 addresses, a /24 IPv4 block. But for the same price, you could get more than 10 to the 26 IPv6 addresses. a /40 IPv6 block. Costco, watch out.
I hope you enjoyed this episode of How the Internet Works. If you like what you saw, please subscribe to our channel. If you have questions or an idea for a future episode, leave a comment below. I'm John Brewer for Deep Core Data. Thanks for watching.